Good morning to all. Myself Sijo N.U, your maths teacher. Today we are going to discuss the very first chapter of 8th mathematics, rational numbers. So our first chapter name is rational numbers. Before we discuss more about rational numbers, we should know something more about different type of numbers. We know that the first type of numbers are natural numbers, or another name is counting number. It is used for counting purpose. Well, then we know what is all number. All number means when we add 0 along with natural numbers, we are getting all numbers. Then we know integers. Of course, negative numbers, positive numbers, along with the 0, we are getting integers. Then only we come to this section, rational numbers. Of course, our first chapter name is itself, it is rational numbers. So what are rational numbers? Well, it is the numbers which we can write in the form of P by Q, where P and Q are integers and Q not equal to 0. That is the definition of rational numbers. Well, so here is the definition. The rational numbers are those numbers, or the numbers which we can write in the form of P by Q, where P and Q are integers, where Q and Q not equal to 0. So examples of rational numbers are, of course, it is a fraction, 1 by 2, 8 by 9. These all are the examples of rational numbers. Now, actually this first chapter, the main points which we covered, which we are going to cover, these are the points. So what are these? Well, it is the properties of rational numbers. So before talk about the properties of rational numbers, we should know what are the properties of something which is familiar to us. Well, let us consider something which is biryani, something like that. We can say, what are the properties of biryani? Why we like biryani? Of course, because of its properties. Well, so what are the properties of that biryani? Its flavor, its color, its taste. These all are the properties of biryani. Yes, just like that, here it's a rational numbers. Well, so these are the main properties of rational numbers. So what are the first one is closure property, second commutative, third associative, fourth one additive identity, fifth one multiplicative identity, and sixth additive inverse, multiplicative inverse, and the last one is distributive property. These are the things which we are going to learn in detail. The first property, the very first property of rational number is closure property. So when we talk about closure property, we know the four basic fundamental operations of mathematics. Of course, those are addition, subtraction, multiplication, and division. So first we can check it is in the case of addition. Once it is familiar to us, this what is closure property in the case of addition, well, the rest of the things are very easy for us. The first one, see here, let A and B are any two rational numbers, then A plus B is also a rational number, then we can say it is closed under addition. In other ways, we can say the sum of any two rational numbers is again a rational number. Then of course we can say it is closed under addition, or we can say the closure property is satisfying in the case of addition. Look at some example. Yes, look at here. Here is a set of rational numbers. We are going to take any two rational numbers out. So here A and B we are taking out. Now let us add this A plus B. What we are getting? We are getting C. If C is another rational number, or if C belongs to this set, we can say closure property is satisfying. Or if we consider the value of A as 5 by 2, of course it's a rational number. Another rational number 3 by 2. These twos are rational numbers. When we are adding these twos, what we will get? Of course, it's a like fraction, we know. So denominator is same as this one, and we can add the numerator 5 plus 3, that is 8. So we are getting 8 by 2. So what we are getting? So 8 by 2 is a rational number. So we can say when we add two rational numbers, we are getting another rational numbers as a result. So we can say addition is closed or closure property is satisfying in the case of addition. Yes, well, hope you understood the closure property in the case of addition. So once it is clear, here is the second case, closure property in the case of subtraction. I think no need much explanation, it is exactly same. So what it says, let A and B are any two rational numbers, then A minus B, here is only the difference, A minus B is also a rational number. Then we can say what? Then we can say it is closed under subtraction, or in other words we can say the difference of, see, the difference of any two rational numbers is again a rational number, we can say it is closed under addition. So let us check. Let us consider a rational number 7 by 4 and another rational numbers 5 by 4. Well, what is the difference of these two rational numbers? Well, we can subtract it, 7 by 4 minus 5 by 4. What we are getting? So we are getting, of course it is a like fraction, so denominator is same, upside subtract, find the difference of the numerator, 7 minus 5, well it is 2. So the answer, the result we are getting a rational number. So in the case of subtraction it is satisfying. So we can say it is closed under subtraction. Yes, here is another case in the case of multiplication. Well, exactly the same definitions are there. So we are just changing the operation. It is in the case of multiplication. Well, so when we consider any two rational number, when we are multiplying it, definitely we will get a rational number as its result. Therefore, in the case of multiplication also it is closed or closure property is satisfying in the case of multiplication. Okay, now we know addition is closed and multiplication is closed and subtraction also is closed. But what about in the case of division? See, when we divide any rational number by 0, the result is not defined. We know 0 is a rational number. Well, when we are dividing any rational number by 0, we are getting the result. Yes, of course, it is not defined. Let us consider 7 by 9, it is a rational numbers, and also 0, we know 0 is a rational number. What will happen? It will divide, of course, 7 divided by 9 divided by 0, of course it is not defined. Therefore, in the case of division only we can say that the closure property is not satisfying in the case of division, or it is not closed under division. Well, we discussed the very first properties of a rational numbers, closure property in the case of addition, subtraction, multiplication and division. I hope you understood that. Now come to the second property, that is commutative. Commutativity. So what does it mean? So commutativity means for any two rational numbers A and B, when we add, we can add those in two ways. That means A plus B. What will be the result? That should be same as B plus A. It's quite simple. Well, in the same way, in the case of multiplication also, when we consider two numbers and we multiply, two ways we can multiply. Well, first we can take the first number A and multiply with the B. So what result we will get? It should be same as, exactly same as B into A. So in the case of rational numbers, this property is satisfying. Well, so we can say in the case of addition and multiplication, commutative property is satisfying. Let us look at some examples. Now consider some examples. The first one, consider two rational numbers 3 by 4 and 2 by 7. Take this as A, the first number, and take this as B, the second rational numbers. Now let us multiply this. So 3 by 4 multiply 2 by 7. So how to multiply? Of course, we have learned that numerator multiply with the numerator and denominator with the denominator. So 3 into 2, that is 6, divided by 4 into 7, that is 28. Now consider we can multiply this as b into a. 2 by 7 into 3 by 4. Check what is the result. 2 into 3, of course, that is 6 divided by 7 into 4, that will be 28. See, in this both case the answer is exactly same. That means a into b, ab is exactly same as ba, that means b into a. Therefore, here we can say in the case of multiplication, it is commutative. In the same way in the case of addition also. Now consider this commutative property in the case of subtraction and division. Let us check whether it is going to satisfy in this case. Consider any two rational numbers. Well, here I am considering 2 by 7 and 3 by 5. Well, let us subtract this. We can find out the difference of these two. Well, we can find out first a minus b. So, what is, consider this as a and this as b. So, what about a minus b? 2 by 7 minus 3 by 5. Well, the result here, we know it is not like fraction. So, what we have to do? We have to cross multiply. Well, we have to consider this one, 2 into this multiply with this, 5 minus this multiply with this, 7 into 3 divided by this multiply with this, 7 into 5. So, what is the result? 10 minus 21 divided by 35. So, its answer is minus 11 by 35. Now, let us find out what about b minus a. So, b minus a, it is as, here its value of b is 3 by 5 minus value of a is 2 by 7. So, it is again it is not like fraction. So, we have to cross multiply 3 into 7 divided by 3 into 7 minus 5 into 2 divided by 5 into 7. So, what we are getting? 21 minus 10 by 35. So, what is the result? Of course, here it is 11 by 35. Now, firstly, a minus b, its value is minus 11 by 35. Here it is b minus a, that is 11 by 35. It is not same. Therefore, we can conclude a minus b not equal to b minus a. So, therefore, we can say this subtraction is not commutative. Well, here is the definition of commutativity. For any two rational numbers a and b, a minus b not equal to b minus a. In the same manner, we can conclude this also. What? In the case of division, a divided b not equal to b divided by a. So, we can say that the subtraction and division are not commutative, but in the case of addition and multiplications are commutative. Well, students, what we discussed today? Yes, the rational numbers and its properties. What are the properties we discussed today? The very first property, closure property, then commutative property. Well, hope you understood those concepts. Thank you. Have a nice day.